In the previous section, we scaled R-series analog I/O by using integer math. By the end of this module, you will be able to describe the data type, module properties, and module methods associated with Compact Rio I/O. Okay, so let's take a look at using Compact Rio I/O. So when you're using analog input and analog output modules with C-Rio, they're going to typically use a fixed point data type. So fixed point data type, we're not going to go into the specifics here, but we will talk about it later in Lesson 7, Signal Processing. But for now, just know that fixed point data type, it provides some of the flexibility of floating point data type, but it also maintains the size and speed advantages of integer arithmetic. So it's going to kind of let you be able to do something close to floating point in terms of functionality, but it's going to be more efficient the way that it's implemented on the FPGA. So different Compact Rio modules can have different fixed point configurations. So the output or inputs of these modules are going to be a fixed point data type. Each one, depending on the module, the fixed point configuration might be different. Also, the methods associated with these modules will be different, and also the properties as well. So we'll take a look at a couple of these examples in the next slides. If you want more specific information on a particular module, you can go to the link in the help that's shown on this slide. So notice here on this slide that we've got a couple of different modules here. They're all analog modules, but they return fixed point data with different configurations. Okay, so the way that the configuration is going to be is it's going to be based on the accuracy and range of a particular module. Some I/O nodes will return scaled and calibrated fixed point values. So depending on the module, the I/O node might have, scaled values that are already in engineering units, and some might not. So let's take a look at an example here. If we look at the bottom, we've got a module there. It looks like it's an analog output module. And to the right, you see its fixed point configuration. We see things like the maximum that it can output, the minimum value, and also the delta. And again, we'll go more into this in the signal processing lesson. So in the middle one there, we have an analog input module. At the bottom, we have a thermocouple module. So we see that the fixed point configuration, the max and mins and deltas, are a little bit different for each of these. So this is just trying to highlight that depending on the module, the fixed point configuration will be specific to a module. Here on this slide, we see different module properties and methods. So each module is going to have its own specific properties that are associated with it, and same with the methods. So if you think about properties are more like attributes of the module, and methods are more like actions that you can execute that are associated with the module. So if we look at the left here, we see at the top left, we have a 9263 module, which is an analog output module. So for that particular module, the only property we have available is module ID, serial number, and vendor ID. If we look at the top right, for that same analog output module, we have a couple different methods available. So we have a method that will do update, wait for update, and also write data. So those are all methods that are associated with that analog output module. If we look at the bottom left, we have an example of a property of an analog input module. So the NI9233 is an analog input module. Notice that one property that it has is data rate. It also has module ID, serial number, and vendor ID. For that same 9233 module, if you look on the right, there are no methods that are associated with that module. So at this point, if you have the hardware available to do this exercise, this would be a good time to do exercise 4.2, where we work with Compact Rio I/O. So in this particular exercise, we're going to acquire 2 thermocouple, and we're going to get that data, and we're going to take a look at it in the FPGA VI and subtract those just to see what the difference between the temperature is. So right now, what we're going to do is I'm going to do a quick demo of the solution, just so you can kind of see what's going on here. Okay, what we have here now is exercise 4.2, and we've got our project right here, and we've got our Compact Rio and our FPGA target. So what you would have done in this exercise is you would have built this particular VI. So if we look at this VI over here, the front panel, we've got thermocouple 0 and thermocouple 1, and the difference between the two. So these are all indicators. If we look at the block diagram, what you would have done is you would have taken the thermocouple I/O. So if we go back to our project and go to module 1, notice that we renamed thermocouple channel 0 as thermocouple 0 and TC1 as thermocouple 1. So they show up with more readable names. And we put this down in a FPGA I/O node, and we've also expanded it so we're reading 2 different values from this same node. Okay, so we're outputting the value of thermocouple 0 here in this indicator, and thermocouple 1 is being output on this indicator, and we're also doing a subtract right here. So we're subtracting those two values and getting a thermocouple difference. Notice that the font here, the color of the font, the color of the wires, and the color of the indicators are all gray. And that gray color indicates that it is a fixed point data type. So notice that it says FXP. That shows that it's a fixed point data type. And again, we'll talk about that more in lesson 7, signal processing. So let's take a look at the values up here. So let me go ahead and stop this. In this case, when we created this VI, we would have run it and compiled it. In this demo, we've already finished the compilation and it's already running. Let me hit stop. So if we look at these values, notice that these are probably not Celsius or Fahrenheit values. So in the case of this particular module, the values that it returns, they are calibrated. However, they have not been scaled for Fahrenheit or Celsius. So to do this, we could either do those calculations on the FPGA, or we could send it up to the host, which can handle floating point operations with ease. Another thing I would want to point out is how fast is this while loop running? If we take a look at it, it's trying to run as fast as possible. We haven't added any timing to it, so we haven't specified a loop rate or anything. We'll talk about that more in the next lesson. Now you can describe the data type, module properties, and module methods associated with Compact Rio I/O. Next, we will handle FPGA I/O errors.